Hi everyone, welcome to another video. Today we're going to have a look at the integrals of exponential functions and some trig functions. Um, I said integrals, we use the word interchangeably with antidifferentiation. So antiderivative integrals effectively mean the same thing. There's maybe a slight difference, but nothing to be sort of worried about here. So when we say the integral of this, we're talking about the antiderivative of something. So let's have a look at this. Remember, integrals are going backwards from derivatives. And so if you have a think about these, I'm not going to sort of go into detail about the sort of where they come from, but if you think about it, you can sort of figure out all of these. So let's do that top one, e to the power x. You know that the derivative of e to the power x is e to the power x. So the antiderivative of e to the x is e to the x. That's by the very definition of e, where that number comes from, is its derivative is itself. So we have that there. Fantastic. Now, also remember, every time we have an antiderivative, we have a constant involved as well. So it will be e to the x plus c. If you think about the derivative of e to the kx, remember that if the k is just a constant, that k will come down the front and get multiplied. So if we're going in the opposite direction, instead of multiplied, it's going to get divided. And so what that's going to be, it's going to go to e to the kx. And I'll put a plus c at the back. And then we're going to have 1 over k. That is going to come out the front as that. And you'll see that if we take the derivative of that, you'll see that y, that's 1 over k. So have a play around with that if you're curious. Have a look. Now, sine x, if you remember remember sine x goes to cos x, and cos x goes to negative sine x. And so the integral of sine x is negative cos x. Okay. And you'll see why that's the case. So negative cos x plus c. Great. And what about if you've got a linear expression within the sine function, so sine ax plus b? It's still the same thing. So you've still got this negative and then cos ax plus b plus c. But also, just like we talked about with this 1 over k business here, with that a there, because of when we take the derivative, going in the opposite direction, we're going to multiply by a. For the antiderivative, we divide by a. So it'll be 1 over a in front of there. And then cos x, well, the derivative of sine x is cos x. So the antiderivative of cos x is sine x plus c. And similarly, that will be, I'll put a negative there, my mistake, sorry. That'll just be 1 over a sine ax plus b plus a constant there. So they're all our simple trig and exponential antiderivatives. So let's go and do some examples of these. Oh, just before I go on, there's a little, some students get confused, or when I say some students, all students, including myself, about when, is it negative sign, is it positive cos? I can never remember. And so the way that I remember is DC negative? So if you remember that, then you can remember. And so what that means is that when you integrate sine, so like here, we integrate sine, or when you differentiate cos, you'll get a negative answer, okay? So you'll see out here, when we're integrating sine, you get a negative answer, okay? So that's how you remember that. And if you differentiate cos, then you get negative sine. And so that little moniker there might help you remember when to make it a negative and when not to make it a negative. Is DC negative? Okay, let's have a look at an example. Okay, let's have a look at the integral of 2e to the power 5x. So let's go straight into it. We can go straight at that. 2 can just sit out the front by itself. Remember that sort of constant can come out of the integral or just leave it out the front sitting there. And then e to the 5x, if you remember, e to the kx, all we do is just divide by what is in front of x. So here it's just going to be e to the 5x, that stays. And out the front, we're going to have 1/5 sitting like that, plus c. When we tidy that up, it's just going to be 2/5 e to the 5x plus c, and that's it. The beautiful thing about integration is that you can just quickly take the derivative to check that you got the right answer. So if we took the derivative of this, that 5 will come down the front, those 5s will cancel out, you'll just left be 2e to the 5x. That c, the derivative of c, disappears, so we can tell that that is the right answer, guaranteed. Let's have a look at this next example. Okay, so here, integral of -3 sine, blah, 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 blah. So let's give this one a go here. So equals, right, that -3 just sits out the front there. And remember, what does sine go to? So sine goes to negative cos because we're integrating sine. Remember, integrating sine here. So because we're integrating sine, that's going to go to negative. And so that's going to go to, I'll just put that, I'll put it like it there if you want to, negative cos 7x. Okay. And we also need to divide by 7. So we're going to put 1/7. I didn't leave myself much space here. I'll just get rid of that negative and put negative 1/7 there. So I just didn't leave much. 1/7 cos 7x. So that's that first part. We'll keep on going to the second part and then come back and clean everything up. Okay, fantastic. We've got 2 cos. Cos goes to positive sine. So that's going to be 2. I'm just going to leave a little bit of space out the front. Sine x over 3. Now, what's a here? What's the number that's in front of x? The number in front of that is 1/3. So I'm just going to write it in a little bit of a dicky way here, but that's 1 over 1/3. Okay, because we're doing the 1 over a. This 1 over a sort of stuff here. And so 1 over 1/3 is going to sit out the front of that. And then because we've just integrated it, plus c. Simplify. -3 times -1/7, that will just be 3/7 cos 7x. And 1 divided by 1/3 is 3, so it's going to be 2 times 3. So that's going to be plus 6 sine x over 3 plus c. And that's all we need. Perfect. Last example. Not much today. Just going to have a quick look at this. Equals, again, 1/4 sits out the front. Sine goes to negative cos. So I'm just going to put that negative out the front. That's going to change into cos. I'll leave some space just in case there's something else I need to put, another fraction I need to put there. So, and then we've got 3x plus pi in the brackets. And then we divide by whatever's in front of x. So that's going to be 1/3 in front of there. If you want, just sort of put the brackets there to make sure. Okay, because sine goes to negative cos. And then we, again, just remember we're dividing by that a. So always divide by whatever's in front of x. In this case, it was a 3, so we divide by 3. Don't forget your plus c whenever you take the derivative, and then tidy her up. So that's negative 1/12 cos 3x plus pi. Hope that makes sense. Hopefully it's nice and simple, just following those rules as given at the top. We'll see you in the next video.